Okay, today in our lesson we are going to focus on lines that are cut by transversal. When you have two lines, whether they're parallel or not parallel, and they're cut by a third line, they form different kinds of angles. So what we'd like to do is look at which lines are transversal, what lines is it going across, and where are the angles located that you see in that particular set of lines. So here in this set, our transversal is line R because that's the line that cuts across both of the other lines. As we go through, we're going to look for a particular set of angles and how are they related to this picture. So first let's look at angle 2 and angle 3. Now what you'll notice is angle 2 and 3 are on one side of this particular transversal. So we would say they're on the same side. They're also between the two lines. Therefore, because they're between the two lines, we call that the interior. So these are same side interior angles. So when you identify the name of an angle, you do it by the location it has to relation of the two lines, as well as maybe sometimes which side of the transversal it is. So based on the vocabulary that we just went over, same side interior also could be called consecutive. Consecutive means that they're in a row, like if you look and you start going across all the angles that are on this side of the line, 3 and 2 have to be consecutively in a row. Now let's look at our next set of angles. Angle 8 and angle 6. So with angle 8 and angle 6 and our transversal still is in the same place, they are not both on the inside of our two lines. They are both on one side though. So sometimes when you look at a picture like this, being able to rotate that picture might be very helpful because you may find that you can't see that particular intersection. But for this one right now, I think it's pretty clear which kind it is. Let's go through where they're located. If you look at this first intersection and you think of this as top right, top left, bottom right, 8 is in the bottom left. And so is 6. 6 is in the bottom left. They're both in the same position within those 4 angles intersection. So if each intersection has an angle in the same position, that is called corresponding. Angles. Okay, in our next one, let's look at angle 3 and 4. Excuse me, 3 and 6 for number 3. So there's my transversal. I've got angle 4 and angle 6. First of all, they're both at the same intersection. That's a pretty good clue that's not going to be one of our new vocabulary words, because look where they are. They're across from each other on the same intersection. We've already studied that name. That's vertical angles. Now you may want to pause the video for a few minutes and try some of these on your own. Or if you're not quite catching on yet, you may want to continue the video to see what other ways we can look at these angles. So if you want, you can pause the video now. Okay, so continuing on with question number 4. Angle 1 and angle 2 are also at an intersection together. So this again is a different kind of angle from vertical because they're not across from each other. They're side by side. And angles on a straight line that are side by side are supplementary because they add up to 180. Or you could say they're a linear pair. That also would be a correct answer because they add up to 180. So in this particular case, we keep pulling back vocabulary words that we've already studied in our previous unit just to make sure you realize if all of your angles are at one intersection, it may relate to ones that we've already studied. If they're at the two different intersections, then it's our new vocabulary words. Now with the angle on number 5, we've got 3 and 7. They are not at the same intersection. They're at totally two different intersections. They are between the two lines, so they are on the what we call interior of these two lines, but they're on different sides of our transversal. So since they're between the two lines, they're on the interior. But they're not like on one side of that. 3 and 7 are on opposite sides of this line. This is on the as far as this transversal is concerned. So since they're on the opposite sides, you'd think they'd call it opposite interiors, but they don't. They call it alternating interior angles because alternating interior angles, well, wait a minute, I didn't spell that correctly. Let me try that again. Alternate interior angles have to be on different sides of your transversal, yet still be between your two lines. So since my two lines M and M have 2, 3, 7, and 6 between them, if we put them on the same side like we did 2 and 3, that makes them same side interior. But if we put them on alternating sides, that makes them alternate interior. So now let's look at number 6, 1 and 5. And you'll notice I keep erasing this every time because I want to focus on different angles each time. So there's my transversal, and I'm going to mark angle 1 and angle 5. First of all, they are definitely exterior angles. They are outside of those two lines, M and N. So they're exterior. Both are exterior angles. But they also alternate because one is above the transversal and one's below the transversal. They are definitely not on the same side of the transversal, so that makes them alternate alternate exterior angles, just like 7 and 3, but the previous answer were alternate interior angles. Now our last example is going to use 5 and 8, so I'm just going to erase this part up here at 1 and move it down to 8. So by moving that one angle, that put both of our angles on the same side of our transversal, so that's part of our answer. Same side. We also have that they're on the outside of line M and line N. They are not on the interior. As you can see, they're exterior angles. So that's one of the things you've got to be able to do. You've got to be able to identify what kind of angle I have based on where is it located in terms of two lines cut by a transversal. Now these lines did not have any special relationship between the two of them. M and M are just two lines that if I can extend them, they'd intersect eventually actually. But sometimes they do have a special relationship. And also, sometimes these angles have different names, like same side exterior angles could also be called consecutive exterior angles. And that's not as obvious with 8 and 5 as it would have been with 2 and 3 on the interior. So let's continue on. It says, identify all the pairs of each type of angle in the diagram. Name the two lines and the transversal that form each pair. So corresponding angles. Again, corresponding angles are angles that are in the same position. So for example, 6 is in the bottom right corner and 7 is in the bottom right corner of the intersection here. So we could say they are corresponding by, well, what transversal are they on? What line do both of those angles touch? They both touch line D. And the other two lines, A and B, that they touch happen to be parallel. So A is parallel to B, is cut by line D. That's what this direction is asking you to do. Identify a pair. And there may be more than one answer for each of these. So that's why you want to definitely turn your picture sometimes and look at it from all different directions to make sure that you've looked for every possibility. In this particular case, I don't think there's another possibility for corresponding though. Alternate interior angles. Those are angles that have to be between two lines. So let's first focus on these two parallel lines being cut by this transversal. If that's the case, then this angle here at 3 is between those two lines, and this angle at 2 is between those two lines, and that would make them alternate interior angles. So angle 2 and 3 by line D is parallel to line E and is cut by line C. All right. Is there another one? Yes, there is, but it is not based on those particular two angles. Let's draw the other direction so you can see that. What if these were my two parallel lines and I was being cut by that same transversal? In that case, angle 4 touches both of those lines and angle 1 touches both of those lines. It's for the same reason, but it is not the same set of lines. Therefore, it would be a totally different answer for alternate interior angles, because you would have angle 1 and 4 are alternate interior by line A and B being cut by transversal C. So that's what we're doing on this page. Now I'd like you to stop the video and see if you could answer a few questions like that. Well, now that you have tried some on your own, let's see if you got them right. So first of all, let's look for same side interior. So if we start with the two parallel lines that are horizontal and let them be cut by transversal B. Let's look at that one first, and then we'll look at transversal A. You'll see that there are two angles that are on the right side of that line that are also between the two parallel lines. And so angle 6 and 5 are same side interior because they fall between line D and E and are cut by transversal B. Now if I try to do that same thing over here on the other side at angle I'll see that those same two angles won't work to name two angles because 1 and 2 would have to be together. So I can't use it on that side. I can't use it on the opposite side of A because there aren't any angles named over there. And I can't use it on the opposite side of B because 3 and 4 is two angles and there's no number down here to go with it, even if it was one angle. So I think that's all of the same side interior ones, because there's just one example. Now, let's see if there's an example from the other direction. What if your parallel lines were A and B, and let's say you're being cut by the transversal D? Well, I think you would have the same problem that you had previously, was those 3 and 4 automatically rules it out at the line D, and I think 1 and 2 would automatically rule it out at E. So I believe there's only one example of that. Now with alternate exterior angles, let's first focus on the fact how many angles are outside on this picture. And when you look at it, 5 is not outside, it's between the two lines. 6 is between the two lines. 7's between the two lines. 3 and 4 are between the two lines. And 1 and 2 are between the two lines, no matter which ones you look at in terms of horizontally. But if you look at it vertically, where A and B are your two lines, then 6 and 5 and 8 are all outside of your lines. Now, when you look at it in terms of, let's start with the line at the top, D. For there to be alternate exterior angles, first of all, we'd have to look at 8, because it's exterior, the two parallel lines that are vertical, and 6 is outside of those two parallel lines of vertical. And for them to be alternating, they have to be on different sides of the transversal, which they are. So that one does work. Now 5 will not work because 5 here at E doesn't have another angle over here to go with it. And it doesn't work with the other parallel lines because it's on the inside of them. So there's only one pair of those, angle 8 and 6. And its line A and B have been cut by transversal D. And then for consecutive exterior angles, for there to be consecutive exterior angles, you would have to have two angles on the outside on the same side of the transversal. So if we just focus on the picture I've already got up here, for that to be true, we would have to be with 8, it would have to be here. And to be with 6, it would have to be below 8, and there's not one there. I also don't think there'd be one with 5, because it would have to be here to go with the 5. So D and E can't be transversals for that. But maybe it could be if we turn the picture the opposite way. So let's go back to the horizontal lines and see if we can find one. So here are my two horizontal lines cut by transversal. Here's my exterior angle. It would have to be here for it to work for that transversal. For this transversal over here, there are no exterior angles. So there aren't any consecutive exterior angles on this picture. So it says, are the angles labeled in the color alternate interior, same side interior, corresponding alternate exterior, same side and exterior? So when you look at angle 4 and 3, they're both between the lines. They are alternating on different sides, so they're alternate interior angles. But when you look at 1 and 2, one's inside, one's outside. So first of all, that rules out exterior and interior angles. That automatically, out of this list, only leaves one answer. But let's see, why is it corresponding? Well, first of all, this is the bottom right, and this is the bottom right, and they're both in the same position around that intersection. So that's why they're corresponding. Over here, we have angle 1 and angle 2 are between the two lines. but they're on the same side of the transversal because they're both on the right side of the transversal. So that makes them same side interior. This one's in the bottom left. This one's in the bottom left. So if you think about it, what I said before, one's inside, one's outside, automatically makes it corresponding if they're in the same position around that intersection. So think through question number 3 here. We have too many lines really to focus on, so let's draw in one set that the two red ones are touching. Angle 1 is outside of the two green lines. Angle 2 is on the inside of the two green lines. They're both on the right side of the transversal, as you can see here on the right side. So that makes them inside and outside. Automatically means it can't be interior or exterior. So let's see if corresponding makes sense. This is the top right, and this is the top right of that intersection. So corresponding does make sense. But when you look at 5 and 6, 5 and 6 are on a totally different set of lines. So let me erase what I have here and focus on a different set of lines. Here is the line 5 and 6 are on this direction with this transversal. So 5 and 6 are both between the two red lines. They're kind of horizontal lines. And they are on the right and the left of the transversal. So they're alternate interior angles. So sometimes you have to focus on specific lines because maybe you have more than 3 lines in your picture. Okay, so in this example, we are looking for angles and actual measurements. So I think I'll stop this video at this time because I'm afraid it'll get too long, and make another video for the second half of this lesson.